Hello, it's laundry day out in the garage. We finally got some sun that came up, so decided to do a load. So this is my large capacity LG washer, and it's running totally on solar right now. I do all the loads in every cycle with hot water. Let's see. And so my hot water heater works at 60 volts, and the washing machine works at 120. So this is only using half my panels, and this only heats water when there's excess solar. I have two 5500 watt panels. Those are actually in parallel. Each has its own thermostat. And this is the controller board. When it sees the PV voltage go over what it thinks the power point voltage should be, it starts drawing just enough current to bring the power point voltage back down to what it thinks is normal. So a lot of times it's at 62.5 volts. My solar panels have an MP voltage of around 60 volts, and we're out in the sun, so it really should be about 59, 58. So I'm several volts over. And I do that because I'm doing laundry and I want to have as much voltage as I can possible. So after the laundry is over, I turn it down. So this is the inverter for the washing machine. It's just an old Harbor Freight, and I've been using this for 3 years. And what I do is feed high voltage into the H bridge. So instead of having, this thing has 7 inverter transformers that step the voltage up to 150. Those were basically disconnected, and I was just powering the H bridge, and so it was taking the 130 volts typically and chopping that up into AC, which is an MSW inverter, and that's what was running the washer. Trouble is, I've been doing that for 3 years, had no problem. This year we have smoke coming down from Canada, and this has been the wettest season. We get like 5 days of rain, lots of clouds, and so I was having trouble with the washer actually stopping when you get into the high loads like spin cycles. So now I have battery assist. Now this is just an old car battery that I got down at the town dump in the recycling. I've tried to revive it a little bit, and it's probably got about 10 amp hours. This is the little charger. This is the LED power supply. These are about 120 watts, and it's supposed to run on 120 volts AC. I run it on 60 volts DC. I've modified it so it puts out 13.8 watts, 13.8 volts, so it keeps the battery on float. And I have a little diode that keeps the battery from feeding into the LED and, discharging it overnight. So this is my transfer switch. You can see one side says house and the other side says wash. We're in wash right now. So in wash, it puts the 2 panels in series, and that makes 120 volts, which is the lower outlet, and feeds that right to the H bridge high voltage section. Now right next to it is a little red switch. This array also feeds the house, and so I have that turned off right now because I want to do operate just on the washing machine, the 4 panels that are out there. And so if I flip the wash switch down and the house switch up, both panels, both 60 volt strings are in parallel, and those feed the house, and they also feed the water heater. And if I put both switches down, this upper outlet box is marked 60 volts. That's what feeds my little trickle charger on the battery. That becomes totally independent. One string of panels can still power the house, but this set of 60 volt string is totally independent, not connected to commons of anything, and that can be used for experimentation. So what I've done right now is this inverter, I've modified that the high voltage inverter section of it normally goes up to about 159 volts. And what I've switched that to is I've modified it with a resistor. I've modified it so it's at 110 volts DC. And that's just below what the power point is with the panels. And so if a cloud passes over, the panel voltage will drop due to the load. And this inverter will instantly start coming on. There's 7 transformers, each one, is a boost up. So each one is about 300 watts. I've disconnected 5 of them. I just have 2 connected, so I can supply like 600 watts. But the system has been working good. Right now, we're at about 50-60 milliamps, and that is actually the charge current. So the inverter is not drawing any current through the battery. I have this switch here so I can disconnect the battery if I didn't want the inverter to come on at all by 12 volts. I'd turn that off. Down here is my power switch. This powers the control circuitry inside, and that's about 100 milliamps or something like that. It's a very low current. In here I have this is an inline fuse. It's a 3 amp. There could be the possibility that I turn on this switch, the inverter switch. I normally leave that off. It's controlled by this other switch. But I could have this off, I'd turn that on, and the inverter would try and power through the low voltage wires, and it would burn up, so a 3 amp fuse protects that. This is the array on the roof. I think these are 226 watt panels, so about a kilowatt of power. 2 are in series for 60 volts, and then I got 2 strings of that, so I can make 120 or 60 volts. But these are east facing. That's a perfect time to do laundry. East facing panels are about the best thing I've ever seen. What you want is early in the morning is to start recharging your batteries. You're running all kind of things, and this is why I can get away with almost nothing for a battery, because early in the morning I have power. This is the spare Harbor Freight inverter I have. Actually, I have like 6 or 7 of these. And if you look down here, there's a 240 K resistor that goes from the high voltage to the sense input of this switching regulator. In any inverter, there's always some sense of the high voltage, and so what I did was I paralleled another set of resistors on this to bring the voltage down. And like I said, the inverter totally shuts down if the voltage exceeds what it's set for. So normally this thing would just sit there and wait for the voltage to drop, and when it does drop, it instantly supplies power, just enough to bring the voltage back up. And I've tied into these diodes, so the power I've brought in is isolated, so the capacitors won't feed back to your charge controller and affect tracking. So it's a neat little system. Like I say, we've had a bunch of clouds. The washer would normally stop. You'd get a DE1 on it when the voltage dropped down too low. The DE1 is a fault indicator that the voltage is too low. And you can also, if you totally lose power quickly, it'll come up with a PF when you power it up again, a power fail. Now normally you can restart from the point that it stopped, but I've had problems with the thing stopping and forgetting where it was. So it's just how it lost power and low voltage at the same time or something like that. For some reason it confuses the washer, 1 out of 5 times. And if you do that, you have to start the load all over again. Or if you're lucky enough to be at the end in a spin and drain cycle, you can reinstitute a spin and drain feature on the washing machine. But yeah, I got tired of having this thing just stop, and so it wasn't a problem for 3 years. And now with the weather conditions, I mean, it's been a miserable summer for the last 2 months. So now, if a cloud passes over, this thing keeps running. I put a power meter on the machine, and we did 5 cycles of laundry, and it averaged out to just under 100 watts for each load. I mean, that's amazing. So a 10 amp hour battery can supply 120 watt hours. That's more than enough. Like I say, it's a real junk battery. I kept it over winter. I never even had it on a maintenance charge, and it's still good enough. But yeah, battery assist. I've gone over to the dark side. I'm now becoming one of those battery people.